All right, I'm just going to redraw the little reaction with how CO2 can impact your breathing. So to start with, we need to have kind of a cause. And so the most common one we talk about is exercise. That's going to increase your CO2 level as your muscles are working harder, doing cellular respiration. It's also going to decrease your oxygen level, but your body senses the CO2 first, and that's more of the main regulator. Okay, so exercise, what it's going to cause is increased CO2 in the bloodstream. This needs to be sensed by a chemoreceptor, and that's going to be in the brain stem, okay, which is not the part of our brain responsible for thinking or emotions. It's this part at the bottom, which then connects to our spinal cord. Okay, and that's where we have any of our other involuntary functions like your heart rate, your blood vessels dilating, anything like that is sensed in the same spot. Okay, so the CO2 chemoreceptor is in the medulla oblongata, which is the brainstem. Okay, and so once that senses that there's too much CO2 in the blood, it's going to send an impulse down the spinal cord and to your rib cage, so your intercostal muscles can be doing faster breathing movements, and also to your diaphragm to help with those breathing movements. Okay, so both muscle groups are going to be triggered. Okay, so that's kind of our next step, is that the diaphragm and intercostal muscles speed up breathing movements. Okay, and that should, assuming that your actual respiration is occurring, that should help to restore your blood concentration of CO2 to normal. Okay, so basically you're going to exhale faster. And so you're going to exhale more of the CO2. At the same time, obviously, you're going to inhale more as well. Okay, but really we're focusing on exhaling the CO2 at this point because we're trying to fix the high CO2 in the blood. Okay, so the result of this is we're going to have lower CO2 in the blood. Okay, as a side note too, we should have increased oxygen as well. That's usually kind of a byproduct. And assuming we get back to a normal level, maybe the exercise has stopped or your breathing has sped up enough that things are returning to normal, then this whole chain reaction is going to stop once the CO2 level drops in the blood. Okay, so this is going to stop that whole chain reaction once we're back to normal. Okay, and so if we're back to normal, and then the breathing returns to normal. Okay, and so just as kind of another thing to think about, so with the oxygen, our starting point could be something like if we're at a higher altitude, or if we had carbon monoxide poisoning, or in some other way just our oxygen was restricted. Okay, but maybe your CO2 levels are normal, so this first pathway might not be triggered. Okay, so the starting point here is we could have decreased oxygen in the blood. Okay, and then this gets sensed first near the heart in your major blood vessels. Okay, so this is the aorta coming out of the top. Just gonna zoom in here. So your aorta, and it could also be in your let's make my pen smaller here, in your carotid artery. Okay, but mainly that oxygen is going to get sensed in your blood vessels. So I'm going to write chemoreceptor in blood vessels in your major arteries. Okay, that's just kind of a one more stop before it still sends a message to the medulla oblongata. Okay, same as before. And then the rest of this whole process is the same. Okay, it's still going to send a nerve impulse down the spinal cord. We're still going to have the diaphragm and intercostal muscles speed up breathing. We're going to inhale or exhale faster. And then the end result for the oxygen would be that you would have increased oxygen in blood. Okay, which we kind of wrote that below as a side note. Okay, assuming that this has been effective, then the whole reaction is going to stop again. Okay, so really we have the exact same thing happening. Something is wrong with your gas exchange. We need to speed up breathing. That should solve the problem. Okay, both methods will use the brainstem, the medulla oblongata, but when it's low oxygen, we're sensing that first in your blood vessels.